Limit as z goes to 7 of z minus 7 over the square root of z plus 9 minus 4. The first thing we're going to do is plug in 7 for each of the z's. That will give us 7 minus 7 divided by the square root of 7 plus 9 minus 4. In the denominator, 7 plus 9 is 16, so we have the square root of 16 minus 4. And the square root of 16 is a 4. So we have 7 minus 7, which is 0, over 4 minus 4, which is 0. We have the 0 over 0 indeterminate form. We will need to rework this. Since we have a root combination, a root involving the variable z, added or subtracted together with at least one other term, that is happening here in the denominator, we can use the root conjugate method. We will be multiplying the numerator and denominator of this expression by the root conjugate. The root conjugate is the same root combination, but opposite sign between the two terms. So it'll be a plus 4. And what we're going to do is put this in the numerator as well, so that we have a form of 1. We're not changing the value, we're just changing the look. So we will have limit as z goes to 7 in the numerator we are not going to FOIL out those two expressions because those are not root conjugates of each other. I'm going to leave it factored, as you see there. In the denominator, I am going to FOIL out, since those are root conjugates, first, square root of z plus 9 times the square root of z plus 9, which will give us a z plus 9. Outside, square root of z plus 9 times a positive 4, that will give me a positive 4 square root of z plus 9. Inside, negative 4 times the square root of z plus 9, which will give me negative 4 square root of z plus 9. And then last, negative 4 times a positive 4, which is a negative 16. The outside and inside terms always cancel in a root conjugate foiling. We will cancel those out. And furthermore, we can add this positive 9 and this negative 16 together. So I'm also going to do that when I go and write my next step. The numerator I'm not going to change. We don't want to FOIL that out, as I've mentioned. So we'll leave that factored as is. In the denominator, z plus 9 and then minus 16 will give us a z minus a 7. So we still have 0 over 0. We haven't changed that just yet, but we've put it into a form where it's become power functions, and the power functions can then factor cancel. I'm looking for factors of z minus 7, since z is going to a positive 7. Those will make a 0 in the numerator and or denominator. I actually have one in each that can be seen now. They can cancel with each other, so I'll go ahead and cancel those out, giving us limit as z goes to 7 of the square root of z plus 9 plus 4. Plugging in the 7, that gives me the square root of 7 plus 9 plus 4. I no longer have the 0 over 0 indeterminate form, so we should be able to get a result of this limit. 7 plus 9 is 16. The square root of 16 is a 4, plus the 4 gives us an 8.